Assalamualaikum warahmatullahi wabarakatuh. Today, consisting of 3 people will be presenting subject MAT183, the subject Differentiation. Our lecturer's name is Ahmad Rashidi Azuddin. Now I will be talking about the team members who make up this group. The first team member is Ali Natasha binti Zubaidi, which is me, with the group ID or student ID of 21819 and 566. The second one is Almina Biha binti Muhammad Shukri 216470012. The third one is Almina Nabila binti Muhammad Shukri 2021-90796. So let's begin with the introduction. What is differentiation? Differentiation really is a function made up of a combination or amalgamation of these classes of functions. The theory offers the following fundamental criteria for differentiating the sum, product or quotient of two functions fx and gx whose derivatives are known, where a and b are constant. The chain rule, the other basic rule of course, allows you to distinguish a composite function if fx and gx are two functions. Two composite functions, f gx, is determined for a value of x by first evaluating gx and then evaluating the function f at this value of gx. For example, if fx equals to sin x and gx equals to x2, then fgx equals to sin x2, where gfx, sign according to the chain rule, the derivative of a composite function is provided by a product, dfdx equals to dfdx dgx. In other words, the first element on the right, dfdx, shows that the derivative of dfx is first determined as usual and that x, wherever it occurs, is substituted by the function gx. In the case of sin x2, the formula produces d sin x2 equal to d sin x2 dx2 equal to cos x2 2x. So what are the applications of differentiation? Differentiation has several applications, not only mathematics and real life, but also in science, engineering, physics, and other subjects. We should have studied how to find derivative of many functions in prior classes, such as trigonometric functions, implicit function, logarithmic function, and so on. Despite we're teaching how to apply derivatives in relation to mathematical principle and real-world problems. Number 1, rate of change of quantity. This is the most insignificant application of derivative to assess the rate of change of a cube's volume with regard to its decreasing size. For example, we may use derivative form as dy over dx, where dy represents the rate of change of the cube's volume and dx represents the rate of change of the cube's size. Number 2, functions for increasing and decreasing. We utilize derivatives to determine whether a given function is rising, decreasing, or constant, as in the graph. If f is continuous function in PQ and is differentiable function in open interval PQ, then f is increasing PQ if fx more than 0 for each x in brackets PQ. F is decreasing at brackets PQ if fx less than 0 for each brackets PQ. F is a constant function in brackets PQ if fx equals 0 for each x brackets PQ. Number 3, tangent and normal to a curve. A tangent is a line that touches the curve at a point but does not cross it, whereas a normal is perpendicular to tangent. Now the tangent intersect curve at p, x1 and y1. The straight line equation that passes through a point with slope m can now be expressed as follows: y minus y1 equals to mx minus x1. The slope of the tangent to the curve y equals to fx at the point p, x1, y1, given that dy over dx at p brackets x1, y1 equals to f, as you can see from the equation above x. Therefore, the tangent of the curve equation p x1 y1 is written as y minus y1 equal to f brackets x1 brackets x minus x1. The equation of the normal is expressed by y minus y1 brackets negative 1 over f brackets x1 close brackets brackets x minus x1 close brackets.
Okay, we continue to the question of graph sketching. Okay, so first we find the x-intercept and y-intercept. For x-intercept, y equal functions equal 0. So 2x power 3 plus 3x power 2 minus 20x minus 2 equals 0. So we just calculate and we get 3 answers for x, which are 1.912, x equal negative 3.0251, and x equal negative 0.161. And for y-intercept, x equals 0, so we use the functions given and we just replace x with 0, so we will get the final answer negative 2. So the point for y-intercept is 0 and negative 2.
Second questions. Okay, we need to find the interval whether fs is increased or decreased. Hence, determine the relative extremum of function, if any. So here we need to let fx or functions equal with 0. So here we will get s1 and minus 2. So we can do a box like this, and we need to enter all the information that we are already get from what we have calculate. So the conclusion is we will get increase, decrease, and increase. So when s equal negative 2, we will get extinct. So the point of this maximum, we get negative 2 and acting. So when x equal 1, we will get minus 9. So that is the relative minimum points, which x 1 and y negative 9.
And next, we need to find the interval where function is converted up and converted down, and determine the inflection point, if any. So firstly, we need to do the function like this, that equal 20s plus 6. So let functions equal 0. So s we will get negative 1 per 2. So we use a book like this, the box like this. So the conclusion, if negative will be covered down, and if positive will be covered up. So when x equal negative 1 per 2, so we will get 9 per 5 from the function that we replace x with negative 1 per 2. So we will get in point inflection point negative 1 per 2 and 9 per 5. Okay, last we sketch the graph of the function. So here we need the point of maximum and minimum points from what we have already calculated. So we just stick to the graph, and we need to draw the graph like this. And the reason why, because this is the polynomial graph.
Conclusion: differentiation could help us to solve various types of problems. In the real world, derivatives are used to determine the maximum and the minimum value of a lot of things, such as profit, cost, loss, and so on. This shows that differentiation is important in our daily life, as it determines the rate of change in value of our surrounding. Finally, with differentiation, we have the ability to find the changing condition on a system. By studying this, we can learn how to control a system to make it do what we want it to do.